In section 12.1, we did the one-way analysis of variance, the ANOVA procedure, and when that's performed and the null hypothesis is rejected using the f-test, this means that there is at least one of the means different, but if we don't know where that difference lies. So in this section, we're going to be looking at the Sheff test and the Tukey test, which would be used to find where the actual difference among the means is. The first one's the Sheff test. Compares two means at a time using all possible combinations. Here is the formula. We have a couple different x bars. We have a subscript I and a subscript j, and those are just the means of the samples being compared. And then the n sub I and n sub j, those are just the respective sample sizes. Then we have our within group variance estimate, and we find our critical value, and it's an f prime. To get that, we multiply the critical value for the f-test by k minus 1. And again, k is our number of groups. There's a significant difference between the two means being compared when the fs, which is what we get from the Sheff test, when that is greater than the f prime value. So now let's take a look at our previous example. We did reject the null, so we knew that there was a difference, at least one of the means was different. So let's run the Sheff test and see where in fact the differences lie. Our first step is going to be to compare, let's compare x bar 1 and x bar 2. So we're comparing the two different means for our first two cities. Capital F sub s to indicate we're doing the Sheff test. And we had a mean of 60.6 minus 54.4. That quantity is squared. Divided by, we have the within group variance. We had as 5.43. And then times 1 divided by our first sample size plus 1 divided by our second sample size. So we do a little computation and we come up with our f sub s, approximately 17.70. So there's our fs value for our first two. Next, we're going to go ahead and compare x bar 1, and let's go x bar 3. So we're looking at Dallas and Detroit. So we had 60.6 for our Dallas mean minus 52.8. That quantity is squared, divided by, and then we have the same denominator again. Our within group variance hasn't changed, and the two sample sizes are the same. And we have approximately 28.01 for that FS. And then our last comparison, we're going to compare Boston and Detroit, so x bar 2 and x bar 3. So x bar 2 for Boston was 54.4 minus Detroit 52.8. That quantity is squared. And then our denominator once again is the same, since all our sample sizes are the same for this one. That will not be the case all the time. And we come up with approximately 1.18 for that value. Now we found all our f sub s's, so now we have to see if we have any significant differences. We have to find our f prime value, which is our critical value. we take k minus 1 times the critical value from our one-way analysis of variance from our ANOVA. So we had 3 total groups, that's our k, we had 3 cities. The critical value from the F-test we ran was 3.89, so we end up with 7.78. So here's what we have to check. If F sub s is greater than our critical value for any of our comparisons, then that means there is a significant difference between those two means. So as we compare, our F prime was 7.78, which means there would be a significant difference between x bar 1 and x bar 2. So we're looking at Dallas and Boston, since theirs was 17.70, which is greater than 7.78, as well as Dallas and Detroit, because their F sub s was 28.0, which is bigger than our F prime. So there's where the actual specific differences would lie. There would not be a significant difference between our x bar sub 2 and x bar sub 3, which would be Boston and Detroit. So that's if we use the Sheff test. Let's see what happens with our second test. The Tukey test. We can also use that to compare means after our one-way analysis of variance, but the sample sizes must be equal for this test. There's our formula. Again, we see the x bar sub I and x bar sub j. Again, those subscripts just represent the different samples that we're looking at. Then we also have our within group variance divided by our sample size. And again, there's no subscript with the n because all the sample sizes have to be the same for the Tukey test. When the absolute value of Q is greater than the critical value for the Tukey test, there is a significant difference between the two means being compared. To find the critical value, we need to use table N in Appendix C. V is your degrees of freedom for within group variance. So let's take a little walk through how we would do the Tukey test. Let's start off the first comparison we have to make. We'll do x1 and x sub 2. So we're looking at Dallas and Boston. So our Q will equal 60.6 minus 54.4. And again, those are just the sample means for Dallas and Boston. Then we have to divide by, we have the square root of our within group variance, which was 5.43, and then our sample size is our denominator. We do our computation and we end up with approximately 5.95. Let's do the same thing. Let's go ahead and compare our first sample and our third sample. So we're looking at Dallas and Detroit. So we have 60.6 minus 52.8. And then our denominator is going to remain the same for each of these. Our within group variance divided by the sample size. And that should come out to be 7.48. The last comparison we need to make, we're going to compare Boston and Detroit. So we have 54.4 minus 52.8. divided by, again, the denominator will be the same for each one of these. .54. Now we have to find our critical value. To find our critical value, let's do just a few reminders. Alpha was at 0.05, that was at the beginning of the question. We're going to use table N. Our K value is 3. We had 3 groups, that's what K represents, is how many groups. 3 cities, so 3 groups. Our V, we said, would be the degrees of freedom for within group variance. We found that by using capital N minus K. Capital N, remember, would be the total of your sample sizes. So we had 5 for each group, so we had 15 minus 3. We ended up with 12. We need all this information for when we use table N. So let's take a little flip to table N. The part of table N we need starts on page 801. We need the alpha at 0.05. There's several pages to this table, just like we saw with table H. And notice over here in the corner we have V and K, so it's not labeled degrees of freedom numerator or denominator, it just has the K and the V. K is our number of groups, which was 3, and then V goes down this first column. V we found to be 12. So 12 for V, 3 for K, critical values at 3.77. Now we have to make our comparison. If the absolute value of Q is greater than the critical value we just found, then we say there is a significant difference between those means. So there is a significant difference between 1 and 2, and also between 1 and 3. And that should be the same result that we got from the Sheff test. The reason why we could use both with this is because the sample sizes were equal. If your sample sizes are not equal, you have to use the Sheff test. If your sample sizes are equal, you should be using the Tukey test.